So in this video we're going to be doing an intro to solving equations with variables on both sides. Now we already know from our notes from last week that an equation is like a balance scale, and we already know that we need to isolate the variable on one side. The goal is to get x by itself on one side. And I even gave you the steps to solving any equation. Last week I gave this to you. So step one is to simplify both sides of the equation. That means distributed property and combining like terms. Step two is to isolate the variable on one side of the equation to get x by itself. So all of last week we were just doing step two because I gave you nothing but simplified equations. And last week we only had x's on one side of the equal sign. This week we're going to be having x's on both sides of the equal sign. So let's move on to a visual example. Check it out. So we have a little picture here of a toy scale, but it'll do. And we're going to call this red cylinder, we're going to call it x. And let's also call these little ones just the value of 1. So let's create an equation here. Let me put a couple of x's. Let me put 1, 2, 3 x's on this side, which is going to be completely off balance right now. And let me put some stuff on the other side. So I'm going to take one of these guys, put it up here, and then, okay, well, how about that? We have 3 x's on this side, and then we have 3 of these single unit, and then we have 1 x over here, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 of those single unit ones. So let's solve this equation that has x on both sides. Well, remember, an equation is like a scale, as you can see right here. And whatever you do to one side, you can do to another side. So I could start removing things. So let's say I wanted to remove 3 of these guys, all right? Let's say I wanted to remove all 3 of these guys, okay? So let's do this. Now, keep in mind, right now, there is perfect equality, right? There's an equal sign between the left side and the right side. As you can see, they're balanced. Now, what I'm about to do is I'm going to remove 3 of them. So 1, 2, 3. Now it's no longer balanced. This is light unless I subtract 3 on this side. So let me remove 3 on this side as well. 1, 2, 3. So now it's still balanced, right? As long as what you do to one side, you do to the other side, you're good. So what about the x's? Well, I have x here and x over here. I don't want x's on both sides. Remember, the goal of solving an equation is to get x by itself on one side. So I don't want x's on both sides of the equal sign. I only want it on one side. So let's get rid of this x over here. But remember, what you do to one side, you must do to the other. So I'm going to remove it. As long as I remove it, then it's still balanced. Okay, so we do have 2 of these x's. So at this point, all I need to do is realize how much each one of these x's is worth. So to do that, let's focus in on what we have over here. What do we really have over here? We have, let me move this a little. We have 1, 2, 3, 4, 5, 6. Now there's 2 x's and there's 6 single unit cubes, or whatever these are, cylinders right here. Since there's 2 x's, imagine I could actually make this into 2 groups, 2 equal groups. So it makes total sense that this one x right here is worth 3, and the other x is exactly worth the same amount, 3. So what I'm going to do here is simply divide by 2. Now, I know that looks weird because we said that they're worth 3, but what actually happened is that we took the left side, which is really x and x, and what did we do? We divided it into 2 because there's 2 x's. We separated them. And over here, what did we do? We took the group of 6 and we divided it into 2 to make a group of 3 and 3. So we really did divide by 2 right there on both sides. And now I could actually remove the x from this side and remove the 3 from this side, and I get my answer, x equals 3. So this is just an intro, just to get you to better understand equations with variables on both sides. The only difference between what we've been doing last week and this week is that last week we had an x on this side, and this week we have x's on both sides, right? So again, it boils down to what's the goal of solving an equation? To get x by itself on one side. So if you ever do have two x's, one on one side, one on the other, you have to get rid of some of those x's. How do you get rid of something? By doing the opposite, right? By removing it. And what you do to one side, you do to the other side. Let's move on. So what I want to do right now is take this exact visual equation that we already solved, and let's solve it algebraically. So I'm going to write down x plus x plus x plus 1, 2, 3 ones, and I'm going to write it down algebraically. Here it is. Check it out. Now, it's kind of ridiculous to write it this way. Well, I'm sorry. It's kind of ridiculous to write it this way because we already know that you could combine the three x's, or yeah, so it'd be 3x instead of that. But I wrote it exactly like that so you could use your notes. Let's go back to our notes over here. Our notes, step 1 to solving any equation. It says simplify both sides. Now, when you think simplify, you need to think two things. What are those two things? Distributive property and combining like terms. So obviously you need parentheses to have distributive property. And there are no parentheses right there, but you do have combining like terms. You could combine all the terms that are alike. And you do this one side at a time. Okay, so you look at your left side, and what could you combine on the left side? You could combine all the x's. X plus x is a total of 3 x's. And of course, the 1 plus 1 plus 1, that's a total of 3. And the equal sign simply comes down. And on the right side, you have that single x. You can't combine it with anything. But the 1 plus 1 plus 1 plus 1 plus 1 9 times, that ends up giving you plus 9. So we did step 1, which is simplify each side of the equation one side at a time. And now we can move on to step 2. Step 2 says to isolate the variable on one side of the equation, to get x by itself. Remember, what you do to one side, you must do to the other. So we go back to our goal of getting x by itself on one side. Problem here is you have x's on both sides of the equation, so let's get rid of this x right here. Now, if I had the 3x over here and 1x over here, I had to get rid of the 1x, and that way I could have x's left over on the right side. So I have 3 here and 1 there, so which one's easier to get rid of? The 1. So let's get rid of that 1x by subtracting, taking it away, right? So x take away x is 0 x's, it cancels out. What you do to one side, you must do to the other. 3 x's take away 1x, that will be 2 x's left over. Bring down the plus 3, bring down the equal sign, bring down the positive 9. And now we have the two-step equations that we've been doing all of last week. We have x on the left side. We need to get it by itself. It's not by itself. There's a 2 right there and there's a 3 right there. We need to get rid of this 3 first by doing the opposite. How do you get rid of something? You do the opposite, right? So what's the opposite of plus 3? Minus 3. And what you do to one side, you do to the other side to maintain the balance. What do I have left? I have a 2x left on the left side of the equal sign, and on the right side I have 9 take away 3, which is 6. For my final step, I need to recognize that I really do have 2 times x right there equals 6. So in order to get rid of the multiplication of 2, I do the opposite of multiplying by 2, which is dividing by 2. And what you do to one side, you must do to the other to maintain the balance. As you can see, 2 divided by 2 is 1, so you simply have x on the left side. Let me move this up a bit. I have x on the left side, the equal sign, and 3 on the right side. My answer is x equals 3.